Alright, here we are. We're talking about complex fractions. So you guys have learned this last year in Algebra 2. But we do deal with a lot of complex fractions, especially when we start going into our trig stuff, okay? Now there are two methods. In reality, right, you guys can go ahead and choose which method you would like, and then keep using it throughout the whole entire year. Now, there might be one method that might be useful in certain cases, while the other method will be used in other cases, right? It just depends on the problem itself. Okay, so we're going to start with method 1. It says change numerator and denominator to one fraction each. Then use the rule for division of fractions, multiply it by the reciprocal of the second fraction, and keep all denominators the whole time. Okay, so I'm going to go and find the common denominator. Common denominator for the first example for the numerator looks like it is 12. So I'm going to multiply this guy by 4. Whatever I do to the bottom, I must to the top. Multiply the other side by 3. And then I'm going to go ahead and rewrite the fraction. So this becomes 4 over 12 minus 3 over 12. That's for the numerator. The common denominator for the denominator is 8. So I just have to go and multiply the 2 by 4. I keep this fraction the same. So this becomes then 4 over 8 plus 7 over 8. And I just go ahead and add through, right? 4 over 12 minus 3 over 12, this becomes 1/12. All over 4 over 8 plus 7 over 8, this becomes 11/8. Okay, now it looks a little bit prettier, right? I can go ahead and, since I have fraction divided by fraction, I can go and multiply by the reciprocal. And then this kind of looks nasty. I'm just going to simplify my numerator, or these guys real quick, right? I can go ahead and look at common factors. I could pull out, what would that be? A 4. So 8 divided by 4 is 2. 12 divided by 4 is 3. So then I could simplify this guy. 2 times 1 is 2. 3 times 11 is 33. So there goes my answer, is 2 over 33. Okay. I'm going to do the same thing for this example. I have a plus b all over 1 over a plus 1 over b. I'm going to rewrite this fraction as the a plus b all over 1 divided by 1 over a plus 1 over b. Okay, I'm going to keep my numerator the same. I'm just going to focus on my denominator. So my common denominator for my denominator is going to be a times b. So all I have to do is multiply by b for my first fraction, multiply by a for my second fraction, and I can go and rewrite. So I have a plus b all over 1, all over, this becomes b over ab plus a over ab. Right, I can go and combine these fractions together, so I'm going to rewrite it one more time. A plus b all over 1, all over the b plus a over ab. Same exact thing where I have this fraction division of a fraction. I'm going to go and multiply this guy on up. This becomes ab on top over b plus a in the bottom. What cancels out is the a plus b, b plus a. It is the same thing using your associative property. So all you're left over is ab over 1 or ab. And that is your final answer. Okay, so this is method number 1, is finding all these common denominators in both the numerator and the denominator. Method 2, it says multiply numerator and denominator by the overall common denominator. This is your hint, overall common denominator, so that the fraction is no longer complex. And then you'll go ahead and do some cancellations to make it into a simple fraction. So as you can see, these are the same examples. I just want to go ahead and show you both methods using the same examples. It'll give you the same answer, or it should. Okay, so if I'm looking at all of my denominators, I'm going to find an overall common denominator. It looks like the overall common denominator is 24. Okay, so I'm going to multiply literally everything by 24. And what happens if I do that, I'm going to say, okay, we're really doing 24 divided by 3 minus 24 divided by 4 all over 24 divided by 2 plus, oh geez, 24 times 7. Guys, I don't even know what that is. Where's my calculator? 24 times 7. Yowza. 168. 168 over 8, right? That's really what it means. And then we can simplify it even more. I have 24 divided by 3 is 8. Minus 24 divided by 4 is 6. 24 divided by 2 is 12. And then going back to my calculator, 168 divided by, is that 8? Gives me 21. Cool. This is a more simplified fraction, right? This becomes 2 over 33, which is the same exact answer as we got in method 1. Okay, this is really what's happening is you're multiplying everything. You're going to go ahead and see in other examples that I'm just going to start canceling things out, right? I do not even have to do the step. All I have to do is go ahead and go to this guy. Okay, so I'm going to do the same thing for this guy. The overall common denominator, I'm going to say, is AB. So I'm going to multiply everything by AB. All right, this becomes AB times the quantity of A plus B all over. If I multiply AB times 1 over A, my A's cancel out. So I'm just left with B. Right, same exact thing if I multiply AB but 1 over B. Right, my B's cancel out and all I'm left with is A. And therefore, these guys cancel out. I'm just left with AB. Done. Okay. So I want you guys to go ahead and try these examples using both methods. Okay. Let's go ahead and do it. Let's do, I'm going to try method 1 for this guy. Same exact thing. Method 1 is finding common denominators all the way out. All right, my common denominator for my numerator fractions is 12. So I'm going to multiply 3 on both sides. Multiply by 2. So we get 3 over 12 plus a 10 over 12 all over 2 over 3. We get 13 over 12 over 2/3. Fraction divided by a fraction. I'm going to multiply it by the reciprocal. And things go ahead and reduce. All right, so we get 13 over 8. Done.
No! Yes!
All right, method number 2. I'm going to find the overall common denominator.
I was his mentor, by the way.
Overall common denominator, it looks like, is 12. So I'm going to multiply everything by 12. 12 divided by 4 is 3. I'm going to think of this guy as 5 times 1 over 6. So I'm going to first simplify 12 divided by 6. I'm going to keep that 5. 12 divided by 6 is 2. All over, same exact process. I'm going to keep this 2. I'm going to multiply 12 times 1/3. Right, 12 divided by 3 is 4. So I get 3 plus 10 over 8. I get 13 over 8. Same exact answer. Cool. Okay. Method number 1. Method number 1 for part B. This is going to be a hefty guy. So I'm going to go ahead and split it up. Method number 1 is going to be super, super long, so I'm actually going to take this full speed. I will go ahead and make another page to do method number 2 in this example. But method number 1, if I'm looking at my numerator, right, my common denominator for this guy is going to be x, parentheses, x plus 1, All I have to do on this side is multiply it by x. All I have to do on this side is multiply x plus 1. And here we go. I get x all over, and I'm just going to combine my fractions. So I have x plus 1 times x plus 1. And then again, my common denominator is going to be x times the quantity of x plus 1. All over. And my common denominator for this guy is going to be the x times x plus 2. So all I have to do on this side is multiply it by x, by x, by x plus 2, x plus 2, and we can multiply it on through. So this becomes 2x minus 2 times the quantity of x plus 2, with the common denominator of x plus 2. Alright, this is what we have. It's a big whole mess. I can go and combine stuff. I can technically go and drop, drop my parentheses, and I can combine the x's, so it becomes 2x plus 1 all over that denominator of x times x plus 1 all over. I will have to do some distribution, so this guy actually becomes 2x minus 2x minus 4 all over x plus 2. What happens to my two x's, right? They cancel out.
All right, what's next?
So I'm left with a negative 4 all over x plus 2. Right, and then I have a fraction divided by a fraction. I can multiply by the reciprocal. This becomes x plus 2 all over the negative 4. And let me see some things cancel out. So the x's only cancel out. I'm left with the 2x plus 1, x plus 2, all over negative 4, x plus 1.
Remember the day where I shot